Mindsetters, welcome to today's Grade 10 Maths Show. Today we have a special revision lesson on Euclidean and analytical geometry. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter at LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
So question 1, we've got triangle ABC is right angled at A. D is the midpoint of AB. So as you can see, we know that that means that AD is equal to DB. DE is parallel to BC. And FD is perpendicular to AB. Alright, so we've got the midpoints of line AB. We know that DE is parallel to BC. That's what they gave us. The first question says, prove, giving reasons, that AE is equal to EC. So prove that AE is equal to EC. So let's write down the proof for part A. Alright. So we know from the given information, we know that AD is equal to DB. Alright, and as I said, every statement needs to have a reason. This is a very straightforward reason that was given to us. So AD is equal to DB, that was given. We also know that DE is parallel to BC. That was also given to you. So therefore, you've got a line that's joining the midpoint of one side of the triangle to another side of the triangle. And you know that that line is parallel to the third side of the triangle. Therefore, it stands to reason if AD is equal to DB and DE is parallel to BC, logical deduction, therefore, AE must be equal to EC because that's what the midpoint theorem says. Okay, the line joining the midpoints, only the line joining the midpoints of two sides of a triangle will be parallel to the third side of the triangle and equal to half of it. So therefore, AE is equal to EC, and your reason here is midpoint theorem. Alright, so that's a very, very straightforward one, and just showing you how you should, giving you an idea of how you should set up your proof in geometry. You start with your statement, and then your statement is followed by a reason for making that statement. Alright, next part says prove that DF is parallel to AC. Now before we do that, I want to remind you guys that geometry, I mean every section in maths is like that, it's building blocks, but geometry especially so. You cannot just forget about anything you've learned in geometry. Simple things like you've learned angles on a straight line add up to 180 degrees. You're going to be using that over and over again. Co-interior, corresponding, alternate angles, remember parallel lines, the angles that are formed between those parallel lines, they come up continuously. You need to know all of your basics from geometry to answer questions all the way through to grade 12. So such an example is part B, where it says prove that DF is parallel to AC. So they want us to prove DF, that one, is parallel to AC. Okay. Now guys, if you look at what you're given, they told you that angle A is 90 degrees. They've also told you that DF is perpendicular to AD. Therefore, if those two angles are equal to each other because they're both equal to 90 degrees, what do you see? What type of angles are those? Well, it forms, remember from grade 9, your fun diagram, right? It forms an F shape, so therefore those angles A and D are called corresponding angles. And we only get corresponding angles being equal when the lines are parallel. So we say angle A is equal to angle D is equal to 90 degrees. Okay, but these are corresponding angles. Right? So therefore, if these are corresponding angles, therefore it stands to reason, logical deduction, DF must be parallel to AC. All right. Nice simple proof for that part B. Part C says prove that BF is equal to FC. So we're making this diagram very, very colorful. We've got BF and there's FC. So in other words, they're asking you to show that F is the midpoint of BC. So how do we do that? Well, let's analyze what we've just done. We've just proved that this line, DF, is parallel to AC. Okay. We also know that D is the midpoint of AB. So therefore, if we just cast our eyes to everything that's drawn in green, all right, D is the midpoint of AB. We know that DF is parallel to AC. Therefore, logical deduction from the midpoint theorem, it implies that F must be the midpoint of BC, because this line DF is the line joining from the midpoint of one side of the triangle parallel to the third side. Therefore, F must be the midpoint of the opposite side. So let's write this down. Okay, so we know this is part D. All right. We know that D is the midpoint of AB. All right, that was given to us. We have just proved DF is parallel to AC. Therefore, that means that F must be the midpoint of side BC. So therefore, BF must be equal to FC, and that's just a deduction from your midpoint theorem. All right. Okay, and I'm sure by now you guys are looking at this and saying, but this is so easy. Yes, it is. All it is just an application. Understand your theorem. Straightforward application. You shouldn't get this one wrong. Shouldn't give you any worries at all. All right, this is now part 2, question 2. Okay, and in this one, we are given that AC is parallel to MK. And in triangle LMK, LA is equal to AM. So all of the information that you're given is depicted in the diagram. All right? So let's have a look here. Firstly, they say prove, giving reasons, that B is the midpoint of LN. So prove that LB is equal to BN. Okay, so let's analyze. What do we have? We know from the given information that AC, the whole of the length AC, is parallel to MK. Okay, we also know that A is the midpoint of LM. Therefore, before we write anything down, we can already see it's similar to the other ones we've done. If B is the midpoint, if A is the midpoint of LM, okay, A is the midpoint of LM, we know that AC, that whole line, is parallel to MK. Therefore, a portion of that line segment, AB, will still be parallel to a portion of the other side. So therefore, AB will be parallel to MN. So if A is the midpoint, AB is parallel to MN. That means that B must be the midpoint of LN. Okay, but remember, it all comes down to how you write it down, because even if you understand exactly what the question is saying and how you need to go about it, if you don't write down the correct proof, you're going to lose some marks. All right. So how do we start? We know that A is the midpoint of LM. LM, and that was given. Okay. We also know that AC is parallel to MK. That was given. Therefore, the little portion of that line segment, AB, must be parallel to MN. Okay, so if the whole line segment is parallel to each other, then obviously little portions of those line segments will still be parallel to each other. So we know AB is parallel to MN. We know that A is the midpoint of LM. Therefore, this must mean that B is the midpoint of Ln. And why can we say that? Well, simply because it's exactly what the midpoint theorem says. Okay, so we have identified one midpoint of the triangle. We've identified parallel third sides. Therefore, it stands to reason that the other side that AB is connecting to, that side, must be the midpoint of Ln. Right. Similarly, if we look at part B, it's saying prove that LC is equal to CK. So in other words, show that C is now the midpoint. Well, we're going to use the fact that B we've just proved is the midpoint. So for part B, all right, we've just proved that B is the midpoint of Ln. So that was proved above. And we know that BC is parallel to NK. And the reason for that is because the whole line segment, your whole AC, is parallel to MK. All right. Therefore, LC must be equal to CK. So we know B is the midpoint. We know that BC is parallel to NK. Therefore, this will only happen if C was also the midpoint of LK. So therefore, LC is equal to LK. LC is equal to CK, and that's because of the midpoint theorem. All right. Okay guys, so far so good. Hopefully you're all following, you're all with me, you understand it, and you're looking at it and thinking, oh wow, this is so easy. I'm going to get 100% in this section, and I hope you do, and I hope you tell us about it as well. Alright, last part, part C. They say prove that BC is equal to a half of NK. So prove BC, that one there, is equal to a half of NK. Guys, there's nothing for us to really even prove here because it's just a deduction from the midpoint theorem. So you literally will say your proof BC is equal to a half of NK, and it's literally just a one-liner. So BC is equal to a half of NK, and the reason there, midpoint theorem. Okay, because that's one of the things that the midpoint theorem says, is if you've got a line joining two midpoints of the sides of the triangle, then that line is going to be half the third side of the triangle.
Now it's time for a break, so don't go away. We'll be right back. Welcome back, Mindsetters. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra, or you can post or comment on our Facebook page. Now, let's do some more revision.
You're given two right-angled triangles, and you're asked to find X and Y. So these are your true triangles. I'm going to name them to make it a bit easier to identify. So we'll call the big one ABC. And let's call the little one D, E, F. All right, for some reason I can't write beyond there, but that is supposed to be a C. Okay, and we are supposed to find X and Y. Now remember guys, they also tell you that these two are right-angled triangles. So therefore we know that that's 90 degrees there, and that's 90 degrees there. Remember, when you look at 90-degree triangles, your right-angle triangles, you need to start thinking of certain things. For example, whenever I see a right-angle triangle, the first thing that springs to mind is the theorem of Pythagoras. And so we need to look for ways in which we can use that theorem. Okay, now we are asked to find x, right? But we can see that side BC is 2x. So therefore, if I found side BC, I'd be able to find x, which is length, EF. How can I find CD? By using exactly what I said you should be thinking about, theorem of Pythagoras. So we've got AB is your hypotenuse. Remember, your hypotenuse is the one opposite your 90 degree. And we've got the shorter side, AC. So therefore, if I'm looking for BC, I can say, using Pythagoras, all right, for some reason I'm going to have to go way down here. I cannot seem to write anywhere on this page. There we go. Maybe we can find a space there. There we go. AC squared is equal to, so AC squared, sorry, plus BC squared. That's what we're doing. We're writing down the theorem of Pythagoras. AC squared plus BC squared, the sum of the square on the two shorter sides, is equal to the hypotenuse squared. So therefore, if I'm trying to find BC, BC squared is going to be equal to AB squared, which was 25, minus AC squared, which was 15. All right, you can then enter that into your calculator. So we've got 25. All right, nothing seems to want to work today. I think it's because it's the first day, so everything's going a little bit pear-shaped.
I think you need to click on the, there's a checkbox there on your
check
left, far
box.
left, on top.
Turn on,
yes.
let's turn off, hey?
Yes.
There we go. Hopefully that does the trick, Abraham. There we go, yes. Okay, so 25 squared. See, as I was saying, nothing wants to work today. What is going on? 25 times 25, let's do it that way, minus 15 squared, so minus 15. Nothing's really working today, Abraham. It's going to be a long, long day. So we're going to get that's equal to 400, right? BC squared is equal to 400, so therefore BC would be the square root of 400, which is 20. Important, guys, remember if you've got BC squared is equal to a square number, you need to square root to get the length of BC. So therefore BC is going to be 20. All right? And we know that BC is also equal to 2x. So therefore 2x is equal to 20. So that means that x must be equal to 10. So that's our value there. And we found that x is equal to 10. We now need to find y, guys. But if you look at what you've got so far, do you have enough information to go straight into triangle DEF and work out the length of DE? Because all we've got so far is simply that x is equal to 10. So if we've only got this one side, there's not enough information just within that triangle to help us get the length of DE. So what we do is, if you look at triangle ABC and DEF, they look suspiciously like similar triangles to me. So all we're going to do is show a little bit of working. We can see that in triangle D, they've marked DEF, they've marked angle D as 35, angle F as 90, and therefore we can work out, using angles of a triangle, we can work out that angle E would be 90 minus 35, which is 55. So angle E is 55, and we can see that in triangle ABC, angle B is also 55. So that implies that angle A, using sum of angles of a triangle, must be 35. And remember, what do we call triangles that are equiangular? Okay, equiangular triangles, we call them similar triangles. Hopefully you all know that. Equiangular triangles, another way we can say that is that these two triangles are similar. Now when two triangles are similar, you get proportions. You get the fact that the sides are in the same ratio. Therefore, using my similarity, we can say, well, triangle ABC is similar to triangle DEF, and I'm going to write this little part down now. This is part of our calculations. Triangle ABC, remember with similarity, your order is very important. So if I've gone ABC, triangle ABC, that means I started at 35 degrees and then I went to 55 and then I went to 90. So I do the same thing in triangle DEF. I go from 35 to 55 and then to 90. So therefore it would be similar to triangle DEF, and the reason for that is they are equiangular, so we show that all the angles were the same. All right. Therefore, following from that similarity, remember the side that you're looking for here was side DE, okay, that one. And the side that we've got is side FE, that one. All right, so using proportion, I can say that AB over BC is equal to DE over EF. Guys, this is nothing new. This is similarity that you've learned before in previous terms and even in grade 9, so you guys should all be familiar with this. Once I've got this proportion set up, that follows because the triangles are similar, remember, I can then put in the values for AB and BC. AB was 25 and BC was 20. All right. We are looking for DE, which is the same as Y, and we know that EF was 10. Then simply by cross multiplying, I can say, well, 20 times DE is equal to 10 times 25, 250. Therefore, DE is going to be 250 divided by 20. All right, so let's just have a look and make sure that is correct. It was DE that we were looking for, and we had FE is 10. Correct. So therefore, let's have a look. We've got 250 divided by 20. Hopefully our calculator's working. And we get an answer of 12.5. So therefore, DE is 12.5, which means that Y is 12.5 because Y was equal to DE. That was given. All right.
I think it's time for a break now, so don't go away. We'll be right back. Welcome back from the break. Let's not waste any more time and get straight back to today's revision lesson.
Okay, here you're given the line joining point C is minus 2. The line joining point C, minus 2, 4, and DXY has a midpoint of M is 1 and minus 3. Find point D. Okay, so let's see what you've been given here. Okay, so we have, and I'm just going to do a rough sketch. We've got C is the point minus 2 and 4. All right, D is somewhere out here. We don't know what the coordinates of D are, but we do know, and they do tell us that the coordinates of the midpoint, so that's exactly midway between point C and D, they tell us this, those coordinates are 1 and minus 3. And they then want you to find the coordinates of D. So a very common question here, what we're going to be doing is using the midpoint formula and working backwards using that formula. Now remember, to find the midpoint of this line CD, we're going to say x coordinate at point D plus x coordinate at point C divided by 2 will give me the x coordinate of the midpoint of line CD, and then y coordinate at point D plus y coordinate at point C divided by 2 will give me the midpoint of line CD. Now we need to create an equation with this, because remember, we've got that the x coordinate can be written as x minus 2 all over 2. The x coordinate of the midpoint, though, was given as 1. So therefore, we know that this value that we've worked out using the midpoint formula will eventually give us an answer of 1. Okay? I can then use that equation to solve for x. So I get x minus 2 is equal to 2. I just cross multiplied there. And we'll get x is equal to, take your minus 2 over to the right-hand side. We get 2 plus 2, which is 4. Okay? Similarly, for the y-coordinate, we see that an expression for that y-coordinate is y plus 4 over 2. And that's going to be equal to the y-coordinate of the midpoint, which we know is minus 3. So we make that equal to minus 3. We then cross multiply and we'll get y plus 4 is equal to minus 6. Therefore, y will be equal to minus 4 minus 6, which is minus 10. Okay. So now we can say the coordinates of D are x is 4 and y is minus 10. And guys, remember with something like this, you can always go back and check. Now, if I've got the x value at point D is 4, let's see if it makes sense. If this is 4, I'll say 4 minus 2. That's going to give me 2. 2 divided by 2. So I'm just using this midpoint formula to see if I get this answer here. So 4 minus 2 is 2. 2 divided by 2 is 1. Correct. And the y value here we got was minus 10. Was that right? Y we got was negative 10, yeah. So if I say minus 10 plus 4, so using this one, minus 10 plus 4 would give me minus 6. Minus 6 divided by 2 is in fact minus 3. So what you can do is you can always get your points, your answers, and then just check and make sure, confirm that it is in fact the right values. All right. All right, guys. Okay, so we're back now with a couple more questions. We've done a bit of midpoint formula. We're ready to use distance formula, gradient formula, and let's apply everything into one big question. This is question 2. Okay, in your diagram, you've got the vertices of quadrilateral F, G, H, I given. Okay, and it's also put and plot nicely on a plane for you. And we ask you firstly, calculate the lengths of sides F, G, H, I. So calculate the lengths. They don't tell you specifically. They just say of the entire quadrilateral. So therefore, you're going to have to use your distance formula and work out the lengths of each individual side. All right, so let's get cracking with that. So this is just a straightforward application, guys, remember, of your distance formula. And while you will be given the formula, you need to know when to use each of them. All right, so let's start with the length of side GH. And the only little trick here is, and the only way you can really get tripped up is if you make a mistake with your signs. Otherwise, it really is just a straightforward application of your formula. All right, so let's look at GH. I'm going to say the x-coordinate at G minus the x-coordinate at, the x-coordinates at H minus the x-coordinates at G, and square that entire thing. Then it's plus the y-coordinates at H minus the y-coordinates at G, and square that entire expression. So it's going to be 3 minus 1 squared plus 7 minus 5 squared. All right, so I'm going to get this is equal to 3 minus 1 is 2, 2 squared is 4, plus 7 minus 5, 2, 2 squared is 4. So this is going to give me root of 8. Okay? All right, so let's move on to the next one, which is finding the length of HI. So that's going to be equal to, and I'm just going to write it straight into the formulae now without going through the whole step of x minus at G at H minus x coordinates at I. So here we're going to get 3 minus 7 squared plus 7 minus 2 squared. Okay, so that's the distance between those 2 points squared, and this is going to be the root of 3 minus 7 is 4, 4 squared is 16, plus 7 minus 2 is 5, 5 squared is 25, And because I'm doing all of this in my head, there is quite a huge possibility that I might add up incorrectly, and hopefully it's keeping you guys on your toes and you're awake and you're checking and you're making sure that I'm not making any silly mistakes. So this is going to give me 6 and 5, that's 11, carry 1, that's going to be 41. All right. So we've got HI, we've got GH, let's move on to FI. So again, just a straightforward substitution into your distance formula. The x coordinate squared, the difference between the y coordinate squared, and we're going to get, so it's going to be 7 minus 2 squared plus 2 minus 0 squared, so it's going to be 5 squared plus 2 squared, and that's going to give me the root of 25 plus 4, so that's going to be the root of 29. Okay. And lastly, we've got the length of GF. So it's going to be 1 minus 2 squared plus 5 minus 0 squared. So this is GF. It's going to be the root of, let's just add that in. Let's go back up there to remind you guys. It's going to be the root of 1 minus 2 squared plus 5 minus 0 squared. 1 minus 2 is just going to be negative 1 squared plus 5 squared. So that's going to give me 1 plus 25 is going to give me 26. All right. So now that we've got all the distances off this quadrilateral, we can already tell a few things. Like, for example, because all the distances, none of the opposite sides are equal, straight away I'm thinking, okay, this can't be a parallelogram, because in a parallelogram, remember, your opposite sides are equal. Okay, so you've got to be thinking as you go through the question in preparation of the last part of the question. Okay. And part B says, are the opposite sides of FGHI parallel? Well, we know they certainly aren't equal. Let's check out the parallel. Okay, so I'm going to do it up here. We've got the gradient of HG. Now remember, with your gradient, it's y2 minus y1 all over x2 minus x1. And the only thing here, guys, is be careful with your signs and remember to get your order correct. So if you're starting with the coordinates at point H, then you need to make sure you get both the x and the y coordinates down first and then go to point G. All right, so 7 minus 5 is going to give me 2. 3 minus 1 is 2. So that just gives me the gradient of HG is equal to 1. All right. Remember, if that side were to be parallel to this side FI, then we know that the gradients are supposed to be equal. So let's check that out. We're going to have y coordinate 2 minus 0 all over 7 minus 2. And that's going to give me negative 2 over 5. So we can see that these are in fact not equal, so therefore our opposite sides, no, they're not parallel. Okay, and what you guys can check, and I'm not going to do it now, I'm going to leave it for you to do, is you can also go and check and you'll see that side HI is not parallel to GF. Okay, so I want you to prove that to yourself, that HI is not parallel to GF. Okay, so it's just a straightforward application of your gradient formula and remembering that if lines are parallel, then the gradients must be equal. Okay, part C, do the diagonals of FGHI bisect each other? Now, in order to understand what formula to use, you need to understand what are they talking about. When they say bisect each other, bisect means cuts in two equal pieces. So if they were to bisect each other, that means that the midpoint of diagonal GI will be exactly as the same as the midpoint of diagonal HF. So if they were bisecting each other, those diagonals will have the same midpoint. So let's check and see if that is in fact the case. Again, I'm going to work on the top here so that we can get everything into our answer without having to go up and down. Okay, so I'm going to look at the midpoint of HF. Midpoint HF. All right. So it's going to be x coordinate at point H plus x coordinate at point F. So it's 3 plus 2, which is 5 divided by 2. And then it's going to be y coordinate at point H plus y coordinate at point F, which is 7, and then divide by 2. So the midpoint of HF is 5 over 2 and 7 over 2. Obviously, if these diagonals bisect, then the midpoints of GI will have to be exactly the same. Midpoint of GI, it's going to be 1 plus 7, which is 8, divided by 2, which is 4. All right? And then it's going to be 5 plus 2, which is 7 divided by 2. Okay, so they've got the same y coordinate, but they don't have the same x coordinate. So in other words, the midpoints are not the same. So therefore, we can say that these lines do in fact not bisect each other. So the diagonals do not bisect each other. Therefore, they do not have the same midpoint. All right. Then lastly, they say, state what type of quadrilateral this is and give a reason for your answer. Now, guys, if you look at the proof and what we've just shown, we've shown that firstly, in part A, we've shown that your opposite sides are not equal. Okay. We've also shown opposite sides not parallel. And we've also shown that diagonals do not bisect each other. So we already see that there's really nothing special enough about this quadrilateral to fall into the definitions of the special quadrilaterals we've done: squares, rectangles, parallelograms, and the rest of it. So therefore, this is just an ordinary quadrilateral, and the reason for it is it doesn't have any of those special properties that we associate with a special quadrilateral. So it's just an ordinary quadrilateral, this one, FGHI. Okay. Have a look at this one, and hopefully, as Queen suggested, you all get on board and you start answering that challenge question. All right, so we're given point A is -6 and 1, and B is the point 0, 3. You are asked to then find the equation of the line joining the 2 points, and then find the equation of the other line, CD, which is perpendicular to AB, and they give you the coordinates or where it's passing through. Okay. Now, you've got 2 points. Let's set this up on a system of axes. Okay, and I'm just going to roughly put the points down where they should be. So we've got A is the point -6 and 1. So A is -6. Let's just say that somewhere there. Y is 1. All right. And then we've got B is the point 0 and 3. So the x value is 0, the y value is 3. That will be on your x-axis. And we can just join those points up. All right, and we'll call this one here point B. And we are asked to find the equation of the line that passes through those 2 points. Okay. Now remember, whenever you're looking for the equation of the line, you need 2 things. You need your gradient, and you need a set of points. Okay, so you need some coordinates. All right. You've got 2 points here. You've got point A and point B. Therefore, we can work out the gradient using our gradient formula. So therefore, I can say the gradient of AB is going to be y2 minus y1. So 3 minus 1 all over x2 minus x1. Now, this is what I was saying with your signs. You've got to be careful with your signs because it's not minus 6. Please use brackets. Otherwise, you may just forget to turn that sign around there. So I'm going to get 3 minus 1 on the top is 2, and then 0 minus minus 6, it's going to become 0 plus 6, which is 2 over 6, which will give me a third. All right, so therefore the gradient of this line is a third, okay? And I just want to remind you guys what you can do now to find the equation. We know the equation of a straight line is y is equal to mx plus c. So the one way you can find the equation is you can substitute your gradient into this, okay, and then substitute a coordinate in to find your y-intercept. Okay, the other formula you can use is this one, y minus y1 is equal to m times x minus x1. So in this one, you've got your gradient, you've got another point, and you can use that equation to find the equation of your straight line. In this case, remember c being your y-intercept, we were lucky because the y-intercept was in fact given to us in the question, because they said B is the point 0, 3. So what do we call it? When the x value is 0, right? This is called the y-intercept. So it is in fact our value of c. So therefore c is just simply going to be 3. So we'll get y is equal to a third x plus 3. Right. And then part B says, find the equation of another line, CD, which is perpendicular to this line, but passing through a completely different point. So, if it's perpendicular, that means it's going to cut it at 90 degrees, right? So it's cutting it somewhere at 90 degrees. Okay, even though my line doesn't look very straight. In fact, let's straighten it out a little bit. There we go. Cutting it at 90 degrees, that's a bit better. All right, and this is your line CD. Okay, they give us a point. They give us that this line is passing through, x is minus 3 and y is 6. So let's just say that's somewhere there. That's a point on the line. That's minus 3, 6. They want us to find the equation of CD. Remember, you're finding the equation of the straight line. You need a gradient. You need a set of coordinates. You've got the coordinates. You don't have the gradient. So how do you find the equation of this line that's now perpendicular to another line? Remember, we discussed this in the summary at the beginning of this lesson. In order to find the gradient of the perpendicular line, we take into account that the product of the gradients of perpendicular lines is minus 1. So therefore, we know the gradient of AB is a third. That gradient of AB times the gradient of CD, the product of those two must be equal to minus 1. So what I'm saying is the gradient of AB times the gradient of CD must be equal to minus 1. Now we know that the gradient of AB is a third, right? So a third times the gradient of CD is equal to minus 1. Okay, is equal to minus 1. Therefore, the gradient of CD, I simply divide both sides by a third. So I get minus 1 divided by a third. You tip and times, and you get an answer of minus 3. All right, so therefore the gradient of CD is minus 3. You could also, if you didn't want to do this in the whole long working out version, since you know the product of the gradients is minus 1, if the one gradient is a third, all you do to get the other gradient is you tip these around. Okay, so it's going to become 3 over 1, and you change the sign. So this is positive, so you change the sign to a negative, and a third times its inverse, negative 3 over 1, will give me negative 1. Okay, so you could also just do it by looking. So the gradient of line CD is minus 3. So now I'm looking at, this is part B. We know the gradient of CD is minus 3. I need the equation. I've got y is equal to mx plus c. Or if you don't want to use that one, you can use y minus y1 is equal to m times x minus x1. I've got a set of coordinates, so I can substitute those in. Remember, they told you it passes through minus 3 and 6. So therefore, y minus, so minus 3 and 6, that was your coordinates. So it's going to be y minus y1, y1 being the y value of your coordinate that was given, is equal to m, which is your gradient, times x minus x1, which is the x value you were given. Again, use brackets so that you don't mix up your signs there. You get y minus 6 is equal to minus 3x. Minus times a minus is a plus 3. Take the negative, multiply it through. So plus 3 times negative 3 is going to give me negative 9. All right. Take the 6 over to the other side, so I get minus 3x minus 9 plus 6 will give me minus 3. All right, and that's the equation of line CD.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Please visit our website, learn.mindset.co.za, to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.